Alright, so we've had sine, cosine, and tangent. And now we're going to look at a simple application of those in that you have angle of depression and angle of elevation. Now ultimately this is just going to be something that, those are two words or phrases, if you will, that indicate to you that you're going to use one of these sine, cosine, or tangent ratios. And it's just a matter of which one are you going to use. Now, let me give you an example here where this comes into play. And it actually in reality does. Like you've got this airplane right here, and it is going to land in this airport right here. See, it's an airport, it's got a bridge. Then, what's happening is the airplane itself is on some sort of a trajectory right now, where it's on this line right here. And as it's beginning its descent, it's going to follow that angle right there. So what you want to look at and what you'll see is that there's an angle right here between its current pointed trajectory, so this line right here, and where it's actually going to fly, this line right here. Now that angle right there, this guy right here, is the angle of depression. So the key is seeing that it's off of an imaginary line that the plane is pointed towards, and it's going to use the line that the plane is actually going to follow. Now you might look at that and go, yeah, okay, so what? Well, what you can do then is if this angle is, let's say, 22 degrees, then some things can now be figured out if other things are known. Like, if it's known how far above the ground the plane is at the exact moment in time it's there, then the plane and its directly down to the ground line, and then the ground itself will make a right angle. Right there. And then now that I have a right angle, as long as I know one of these distances, like let's say currently the plane is 1,600 feet above the ground. It's rapidly descending. It's coming in. I could tell you how far it's literally going to travel, and I could also tell you how far from this point right here on the ground directly beneath the plane is from where it will touch down on the runway right here. Now if you're savvy, you might look at this and say, wait, hold on a second there, letter. That 22 is not inside the triangle. That's true, but this entire angle right here is also 90 degrees, which you can see because these two lines would indeed be parallel. So if you needed what the measure of this angle right here is, which obviously you do, you would just take 90 minus 22 to get 68. So that's 68 degrees. So now we're going to go to that sine, cosine, tangent thing we've been doing, where I've got a 68 degree angle. The opposite to that 68 is over here. I know what the hypotenuse is. It's this line right here, the longest line, leaving this for adjacent. And the two values are in adjacent and hypotenuse. I use my some old hippie trick, and I find that the cosine of 68 is going to equal the adjacent 1,600 over the hypotenuse is x. And this is a problem where I don't know the hypotenuse, so I need to switch and divide. And so then I would have that x is equal to 1,600 divided by the cosine of 68. And then that comes out to a nice solid 4,271-ish miles, or whatever the distance is. I'm sorry, not miles, feet. So 4,271 feet for the plane to actually travel along this trajectory right here, that hypotenuse. That is utilizing the angle of depression. Now, the angle of elevation is actually no different, and let's look at that. So let's say we got this homeboy right here. He's flying a kite. Simple enough, and he's pretty good at it. He's got a nice little taut line there, and it's flying nicely. And then now we need to figure out some distances, and weirdly we know some angles. Like say for example, we know the angle that is between him and the ground to be a nice solid, let's call it 55 degrees. And then we also know that the kite string with full extension is 62 feet. This kid can fly a kite. And what we want to know is exactly how high off the ground is this kite as we stand here. Because math or something. No problem. Well, we know there's a perpendicular line to the ground that goes from the kite to the ground. So it's at a right angle. So here we go. And that length is going to be the missing value. And then once again you look and you say, well, here's trigonometry again. I've got my angle, the opposite is the value I'm interested in, the hypotenuse is the value I happen to know, the adjacent's not going to come into play, so which one of the three trigonometric ratios comes with opposite and hypotenuse? That's sine. So the sine of the angle, which in this case is 55, is the opposite, which is x, over the hypotenuse, which is 62. And in this case, we are now going to multiply these two values. So you have sine of 55 times 62, which equals about 50.78. So the kite's about 51 feet above the ground. Now all of that is the angle of elevation. And by all of that, what I mean is the actual angle. Because in the previous problem, the angle of depression was up here, where there's a kite, and then the angle was there of this imaginary line. But the angle of elevation now comes off of that line, the line on the ground, and right here, this hypotenuse. That's your angle of elevation. So it's just quite simply identifying, plugging in values that are given in the appropriate spots, and then solving for the missing variable using the sine, cosine, tangent, some old hippie thing we've been doing. And that's it, and that's angle of elevation and angle of depression.